So what we're going to be looking at here is we're going to be looking at how we can substitute into an equation for the purpose of figuring out the value of one variable. Now, this is the precursor for being able to use the property of substitution in order to solve a system of linear equations where we'll actually be solving for the value of both variables. So one of the things that must be true is that you have to have what we call an isolated variable. So in other words, one of the equations should be have a variable all by itself. So for both of these, I already have set them up so that they do have that, and that's what we're going to be practicing. So in this one, x is equal to a constant, and in this one, we have y equals a variable expression. So sometimes we may be able to end up with a solution where we have another variable equals a number. Sometimes we may end up with a solution that just tells us the other variable equals another expression. And that's okay. Okay, and so just remember what equal means. Equal means that two things are exactly the same. So in this case, when it says x equals -8, it's saying that they are exactly the same. Up here, it's saying that 7 times x plus 3 times whatever y is has to combine to give us exactly -32. So over here, when it says y equals 2 times x minus 5, I can replace any y value in this system with 2 times x minus 5. Okay, so let's go ahead and look at how we use substitution. So we have, I'm going to do the one on the left, and over here it says x equals 8. So I have an isolated variable, x equals -8. And so what it means is that in the first equation, if I go ahead and I take that same equation, every place that there used to be an x, I can replace it with -8 because they are equal to each other. So that's what I'm going to do. And now I have an equation that's equivalent to it because I'm replacing two things that are equal. So 7 times -8 would give me -56 plus 3 times y because I can't do anything with that. And it still is equal to -32. So I'm just simplifying my equation. And now I'm going to solve my equation. So I'm going to do inverse operations by adding 56 to both sides. -56 plus 56 is 0, leaving me 3 times y on the left. -32 plus 56 is 24 when I combine like terms. And now inverse operations to finish solving means I have to divide both sides by 3. Which gives me y is equal to 8. So now that I have values for both x and y, I can verify if it actually solves this equation by going ahead and replacing the x and the y with the values I calculated. So we knew from before we had x is -8, and we just calculated x is +8. So let's see if it works. So 7 times -8 is -56. 3 times 8 is 24. Adding those together, negative plus a positive, I have more negatives, so that's a negative. And 56 take away 24 is 32, which is what it should be. So I know both sides are exactly the same. I know my solution is correct. Okay, so I verified my solution for this one because I can. And now if this was my objective was to solve the system of equations, that would tell me that the coordinates of the point where the two lines would intersect would be at -8, +8. Okay, now the second one, I'm not actually looking for the solution to the system of equations. I'm just looking at how we substitute. But the difference is that this one equation, even though I have the variable isolated, it's in y equals form this time, it's not equal to a constant. It's just telling me another expression, and that's okay. But it's just that I'm going to replace it with an expression. So this time I'm replacing the y with what it's equal to. So I'm going to go back to my first equation, and I'm going to put parentheses in place of the y. And I'm going to go ahead and I'm going to put that expression that y is equal to for my second equation, and that's what I'm going to plug in for my y. And now, as we learned previously, we use a distributed property and simplify. So we have 5 times x, negative 4 times 2x is negative 8x, negative 4 times negative 5 is positive 20, and it's still equal to 11. So now we combine our like terms, which gives us 5 minus negative 8, 5x's minus 8 times x would give me negative 3 times x plus 20, which is 11. And now I would add or subtract 20 from both sides, excuse me. So that leaves me negative 3x, because 20, take away 20 is 0. And that gives me negative 9 over here. And I'm going to finish it up over here. So I have negative 3x equals negative 9 is where I left off. So I'm going to divide both sides by negative 3. And I have negative divided by negative is positive. 3 divided by 3 is 1. Negative divided by negative is positive. 9 divided by 3 is 3. So it gives me a value for x, but I still don't know exactly what y is equal to. But if I wanted to find out, I could just go back and plug it in here, and I would figure out what y is. But for right now, we just want to go ahead and show how we're doing. Substitution can help us go ahead and form a solution in our other equation. Okay, so our substitution step requires us to have one equation that has a variable isolated. So that's our isolated equation. So in this case, the isolated equations were y equals 2 times x minus 5 and x equals negative 8. Then we substituted, that part that wasn't, so the negative 8 for the x, and in this case, the 2 times x minus 5 for the y, okay, into the other equation, and remembering to use parentheses for what we're replacing the variable with in the other equation. Then we solved our new equation. Okay, and later on, these are the final steps, step 4 and step 5, okay, are what we're going to be doing as we go ahead and learn how to solve the whole entire system. But for right now, we just want to go ahead and do substitution and solve the new equation that we're creating, or the revised equation, I should say.